Hello everyone, happy to see you here. Today we have great, quick and relaxing algebra question. We need to solve this question for a and b. We know that the sum a plus b equal to 12 and a product a times b equal to 24. If you have your solution, your answer, you can also write it in the comments below and then we will check our answer, so it will be really interesting. What do you think is the correct solution to this question? And you can also use your intuition to solve it for a and b. Okay, so what is the main method? How can we solve this type of question? First of all, let's express our b from the first equation, or you can also express our a, doesn't matter. I'm going to express b. So our b equal to 12 minus a. 12 minus a. And right now, I'm going to plug in, instead of this b right here, I'm going to plug in this 12 minus a to the second equation. So let's do it right now. We have a times 12 minus a, 12 minus a, equal to 24. And right now let's simplify it. We have a classic equation only with one variable. So that's why let's multiply our a by these parentheses. So we have 12a minus a squared and minus 24 from the right side equal to 0. And right now, if we look closely, this is a classic quadratic equation, but only with one difference, with one thing. We need to change this order real quick because we prefer our squares on the first position, our constant on the third one, and this expression on the second position. So that's why we write minus a squared on the first position, plus 12a on the second position, and minus 24 on the third position. And the last thing, this is a quadratic equation, but we don't like this negative sign right here. So that's why my quick recommendation is to multiply both sides by minus 1 or divide. So let's multiply both sides by minus 1. So we need to change all these signs to the opposite one. So we have a squared minus 12a and plus 24 equal to 0. And right now, I hope you understand this solution until this moment. We have a classic quadratic equation, so that's why let's solve it. And of course, maybe a lot of students might be watching this video right now, so that's why I'm going to use a classic method of coefficients. Of course, this is up to you. You can also use your theorems. My quick recommendation, I'm going to use a classic method of coefficients. So first coefficient a equal to 1, b equal to minus 12, and c equal to 24. So right now we know everything, so that's why let's plug in these coefficients into this spot. I'm going to solve this real quick for discriminant. So b squared minus 4ac, so equal to b squared, so minus 12 squared minus 4 times 1 and times 24. So our discriminant is equal to, so minus 12 squared equal to 144 minus 4 times 24 equal to 96. So our discriminant is equal to 48. It means the discriminant is positive. So right here we have two roots, two real number roots. So right now let's plug in this discriminant into this spot. So we have a first and a second equal to minus b plus minus square root of discriminant and all over 2a. So that's why minus b minus 12. So we know everything. We know these coefficients. We know discriminant right here. So that's why let's plug in everything into this spot. So plus minus square root of discriminant square root of 48 and all over 2 times a times 1. Okay, so let's simplify it. Minus 12 equal to 12. Plus minus square root of 48. How can we express this 48? We can express the 16 times 3. Of course, as 24 times 2, but my quick recommendation is to express this as 16 times 3 and all over 2. And why do we express it as 16 times 3? Because right now we can easily write it as not like a square root of product, but product of two square roots. So 12 plus minus square root of 16 times square root of 3 all over 2. And right now, why do we express 16 times 3? Because 16 is a table case, and square root of 16 equal to 4. So 12 plus minus 4 square root of 3 all over 2. And the final trick, we're going to divide our numerator by 2. So we're going to divide 12 by 2, so we have 6 plus minus 2 square root of 3. Of course, this is a quick method. If you want to solve this question step by step, you just have to factor 2 from here. So 2 and parentheses 6 plus 2 square root of 3. But this is a little bit faster method, so that's why we have our answer. So our a first equal to 6 plus 2 square root of 3. Yeah, and our a second equal to 6 minus 2 square root of 3. This is not our pair. This is not a first, a second. These are not our pairs. This is only a, but don't forget about b, because in the beginning b equal to 12 minus a. So that's why let's solve for b first right here. So we have b first equal to 12 minus a first. Yeah, 12 minus a first. So b first equal to 12 minus a first equal to 6 plus 2 square root of 3. And let's simplify it. So b first equal to 12 minus 6 minus 2 square root of 3. 12 minus 6 equal to 6. So b first equal to 6 minus 2 square root of 3. And as you can see right here, we have two absolutely symmetrical pair. We have 6 plus square root of 3 and 6 minus 2 square root of 3. So that's why I hope you understand that b first, b second will be 6 plus 2 square root of 3. Just look at it. So b second equal to 12 minus a second. Yeah. So we have b second equal to 12 minus 6 minus 2 square root of 3. So we have b second equal to 12 minus 6 and plus 2 square root of 3. And as I said before, b second equal to 6 plus 2 square root of 3. So we have two absolutely symmetrical pairs. Here we have a first, b first. So let's write it as an answer. And then I'm going to check it real quick. So we have our answer. So 6 plus 2 square root of 3, this is our first root, and 6 minus 2 square root of 3. This is our second pair, yeah. And right here we have 6 minus 2 square root of 3 and 6 plus 2 square root of 3. So we have two pairs, first pair and a second pair. And in the end, let's check our roots. First of all, let's write our system of equations. So a plus b equal to 12. And AB equal to 24. And one really interesting trick, one really important hint right here, we have addition and multiplication, and we have the two absolutely symmetrical pairs, so we don't need to check both of these because a plus b equal to b plus a, so that's why we don't need to check both of these. Let's check, for example, this one. So we have 6 plus 2 square root of 3 plus 6 minus 2 square root of 3 equal to 12. This is absolutely correct because right here we can cancel this thing. 6 plus 6 equal to 12. So addition works great. Our roots are great if you're talking about addition. Right now, let's check real quick our multiplication. So we have 6 plus 2 square root of 3 and times 6 minus 2 square root of 3. Okay, this is our multiplication, and right now let's solve it. First of all, we have difference of squares. This is our formula because we have a plus b times a minus b. So in terms of our formulas, in terms of our identity, this is our difference of squares. Yeah, if we write it, I'm going to write it on the bottom. So we have x squared minus y squared. Yeah, we have x plus y right here times x minus y. Okay, so this is a difference of squares. So 6 square minus 2 square root of 3 square. So equal to 36 minus 2 square. We have 4 times square root of 3 to the power 2 equal to 3. So 4 times 3 equal to 12. So as a result, right here we have 24. So our multiplication works absolutely perfectly as well. So we prove it. So right here we can easily say that this is our proof. This is our check to this. This is our question. Yeah, so our roots are absolutely great. So we can also check the second pair, but as I said before, because we have like symmetrical roots, so it doesn't matter. You can also use this root for a proof, or this one, doesn't matter. You don't need to check both of these because we have addition and multiplication, and a plus b is the same as b plus a, and a times b is the same as b times a. So it was my solution to this question. I really hope you understand it. I really hope you learned something new, but definitely don't feel bad if you got this wrong. If you need help with any of these classes, I have a lot of questions on my YouTube channel, more than 600 Olympiad questions, entrance examination, and another type of question. It will be really interesting to see you here and to learn something new. It's my main goal, to make math clear and understandable for everyone. So it was my solution to this question. I really hope you understand it. I really hope you learn something new. Wish you all the best in your life. Take care of yourself and have a great day. See you in the next videos.